my refrigerator is about to come on, and that's that little blue light flashing. And my inverter doesn't turn on until the refrigerator is going to run. And I decided to put a little delay timer on it. Over here I have a little, in that cover here, I have a solid state relay. And that allows me to operate the inverter. So right now I'm using a voltage relay. As you can see, the voltage is coming up. I'm charging up a capacitor. When it reaches 5.6, I think it is, volts, it'll turn on that solid state relay because the inverter is already running. And pretty soon, okay, so I've instituted this little time delay, and now you can see the current flowing to the refrigerator. Now, what I had initially is I had some of these timer boards. I actually had a really nice DIN rail timer that was perfect for this, and I didn't pack it, forgot it, or hit somewhere I can't find it. So I had this little timer board. But if you wanted to have an on delay to it, the only way you could do it was institute like a 90-second delay and then have the thing on for 999 seconds, which is around a little over 16 minutes. So that wasn't long enough. The inverter was staying on, but the refrigerator was turning off. So I had a bunch of these little voltage relay boards, and so I decided, like, you know, I could do this with a FET. So if you had a relay and a FET going right to this input here, once it reached about 4 volts, the FET would turn on. You could have a simple delay. These voltage relays have about 100K input. Now there's a little bit of a mystery here because if I remember right, these are around 100K. You know, that only makes sense that you have a high value sense resistor. And so this is a 1000 microfarad 16 volt capacitor. And I'm charging, I had a couple resistors in parallel, and it comes out to 26K. And this thing will not get above 6 volts. So it should have gotten up close around 9-10 volts easily. So either I have some really excessive leakage in this, which could get better. I don't know. But anyways, what I have is, because you want this thing to reset, I have a diode to discharge the capacitor when the thing turns off. And because this is in a fairly high resistance, the control system, I had to put a 2K resistor here to ensure that there was a discharge to ground. But these little common voltage relays, I think I paid like $1.70 for them on AliExpress, and there was some shipping. But you set it up in H2, which is the discharge mode, so it turns on at 5.6 volts. It won't turn off till it reaches 5.1. And that's nice because I'm just charging from the power supply. It's 14 volts usually, but if the refrigerator comes on, that voltage drops. You could get a little drop in voltage, and you don't really want it to drop out like that. So yeah, you set the voltage a little bit lower, so it'll never drop out on its own, but it works as a timer. And so you know, you could have inverted this and had it charge the capacitor with the resistor, you know, just totally inverted with this. But the voltage relay, you know, can be set up to turn on, turn off, so you have a charging or a discharging type of setup for the relay, and you don't need to invert them But if you had a FET here, you could. But yeah, if you had a FET sitting right here, source to ground, gate, and the drain going to a 12-volt relay, you could accomplish the same thing. But I thought, well, instead of sitting around playing with a voltmeter, I got this thing I could read directly. So I got to figure out what that mystery is why it doesn't climb up any higher in voltage than 6 volts. But yeah, you can make do with whatever. If you need a time delay, a voltage relay will work.